All right, and finally the last question, which is very, very interesting, the puzzle. So first thing to note is please change the scale to 10 cm. It's not 1 cm. So you are given some data. You're supposed to find where is the object distance for object 2 and where is the image or object height for object 2. And so first up, let's just put in our principal axis and our lens. Again, note how you draw the converging lens, double-headed arrow. And let's just plug in the data from object 1. So object 1 is found here. Please ignore what you see here, the image 2 is supposed to come out later on only. So object 1 is here, image 1 is here. I draw it to scale. So this is 10 cm height and 40 cm away. Same for image 1. So I will first connect the object image with a light ray. Alright, so this is the light ray. And then I will do a second light ray. And this actually tells me where the focal point is. So with this information, I now know the focal point is 20 cm. The lens focal point is 20 cm. Focal length is 20 cm. So 2f is 40 cm. So I'm marking all the f and 2f's over here. So right now we can move on to object 2. We are given that object 2 is here. Image 2 is given exactly 60 cm away, 20 cm height. So I draw in image 2 here. And again, same technique. I will just connect image 2 to the optical center of the lens and just extend it all the way back. Okay. Then I will draw in the second light ray. From here, image 2, this light ray is supposed to pass through the focal point. So I just connect here to here, extend it to the lens, and then draw in a horizontal line. So it's like reverse engineering the steps. We usually draw the light rays from the object all the way to the image. Now we draw in the other way, from the other way around. Okay, so with that, we can then find the intersection point here. That is the object number 2. And then doing some measurements, U2 is 30 cm and H2 is 10 cm height. Therefore, when the image is, when the lens is now taken in part B, what happens is that there's more refraction, there's more bending. So the degree of bending will be higher. So when the lens is thicker, the image will still be inverted, it will be real, but it will be smaller because the thicker lens will have a very small focal length. This one you all must know. And the light will refract more and converge more quickly at the distance that is nearer to the lens. This makes the image actually nearer to the lens and also smaller.